Okay. So I always kind of go back and forth with myself about, sharing this, but so this process that we went through here, in order to calculate the confidence interval using the inverse distribution function in order to convert an area into a z-score. Um, there is a calculator function in both Texas Instruments and NumWorks calculators that will create uh, intervals, confidence intervals for you. Um, but I would highly recommend that you use this as a check for your answers. Um, because the central message that you want to continue to imprint on your brain is you want to get really good at visualizing this image of a distribution and these critical values, the significance level and the confidence level on the inside. And the only way that you do that, is by doing it, is by drawing it and implementing it. Um, if you start using functions like this from the outset, um, you're not going to learn and feel comfortable with this concept. And we're going to keep using this concept over and over and over again. And there won't be, functions for everything that'll just do everything for you. So I would highly stress that you use these functions as a check for your answers. Um, so having said that, where can we find these interval functions? So on the Texas Instruments, if we go to stat, then tests, we're doing a Z interval. So let's see here. Let's go to that. So if we hit stat, go to the tests menu. And then if we scroll down, there's one called Z interval. So select that one. And you can input data, from one of your lists, like a list editor, or you can enter in stats. So we're going to enter in stats. Now this is where it's asking us for a standard deviation of the population, a point estimate, sample size, and a confidence level. So from the last problem, if we put 3, 68, 36, put that in there, 3, 68, and 36, with a confidence level, I think it was 90%. Yeah, 0.9. We can hit calculate, which I'll do here in a minute. For the NumWorks people, I believe there's an inference app and then intervals. So let's do that. So we'll hit home. Let's see, yeah, inference app, which I think might be the first time you've seen this. Go to intervals, click OK. And we want a single mean interval. So notice it says T interval, Z interval. We want a Z interval. And we could use a data set or we could use statistics, just like with the Texas Instruments calculator kind of gave us, we could use data or stats. We can use data or stats. We're going to use, input statistics. Okay, our point estimate was 68. Standard deviation was 3. Sample size was 36 with a confidence level of 0.9. And here it gives you the critical value, which is what we calculated as an intermediate step. We also calculated the error, right, at 0.822. Let's see here. So we want to go to next. And so it gives us the confidence interval, 67.1776 to 68.8224. And the equivalent expression is going to be 68 plus or minus the error, 0.822, which is what we had for an answer. Over here on the Texas Instruments, we can click enter. And you can see it gives us this 67.178 and 68.822, which are these two numbers. Okay, this is where you could put the confidence interval with a lower bound and an upper bound. But the NumWorks also gives it in this format. So if you had the answer in this format, you'd have to do a little bit of work to, put it in this form. Okay, so just realize that these two functions are here in your calculator. Please use them. I would recommend that you use them to check your work. The important part here is to get used to and get really good at representing your problems, by drawing these distributions, labeling the parts of the distribution, and using that to clear your head and see clearly what it is that you're calculating and what you're doing and what you're understanding. Okay, and use it to check your answers. All right. So let me know if you got any questions about that.